Hey there, science fans! Welcome to another exciting episode where we explore the wonders of data and statistics. Today we're diving into the fascinating world of statistics, specifically measures of central tendency and variability. These concepts might sound complex, but they're actually quite intuitive once you get the hang of them. Now don't let those fancy terms scare you. Measures of central tendency include the mean, median, and mode, which help us understand the average or most common values in a dataset. On the other hand, measures of variability, like range, variance, and standard deviation, tell us how spread out the data points are. We use these measures every day to make sense of the world around us. For instance, when you check the average temperature for the week, you're looking at a measure of central tendency. When you see how much temperatures fluctuate, you're considering variability. From understanding test scores to analyzing sports stats, these tools help us interpret data and draw meaningful conclusions. Imagine you're a student looking at your test scores over the semester. The mean score gives you an idea of your overall performance, while the range shows the difference between your highest and lowest scores. Similarly, in sports, analysts use these measures to evaluate player performance. The average points scored per game is a measure of central tendency, while the variability in performance can indicate consistency or improvement areas. So, buckle up as we unravel these statistical mysteries together. It's going to be a wild ride. By the end of this episode, you'll have a solid understanding of these fundamental concepts and how they apply to real-world scenarios. Whether you're a student, a professional, or just a curious mind, mastering these tools will empower you to make informed decisions based on data. We'll start with the basics and gradually move to more advanced topics, ensuring that you grasp each concept thoroughly. So, grab your notebooks and let's get started on this data-driven adventure. Remember, data is all around us, and understanding it can unlock countless opportunities. Whether you're looking to excel in academics, boost your career, or simply satisfy your curiosity, knowing how to interpret data is a valuable skill. So, stay tuned, stay curious, and let's dive deep into the world of data together. The journey might be challenging, but it's also incredibly rewarding. Let's make sense of the numbers and uncover the stories they tell. Thank you for joining us on this exciting exploration. Until next time, keep questioning, keep learning, and keep diving into data. Let's start with the mean, our friendly neighborhood average. You've probably encountered it before. Remember calculating your average grade? That's the mean in action. We find the mean by adding up all the values in a data set, and then dividing by the total number of values. Easy peasy, right? However, the mean can be a bit sensitive. Extreme values, those far from the others, can throw it off balance. Next up, we have the median, the middle value in a data set. The median is a crucial concept in statistics and data analysis. It represents the point that divides a data set into two equal halves. Unlike the mean, which can be heavily influenced by outliers or extremely high or low values, the median provides a more accurate reflection of the central tendency when dealing with skewed distributions. Think of it as the peacemaker, always finding the center. To find the median, we arrange our data from least to greatest. If we have an odd number of values, the median is the one right in the middle. For example, if we have the numbers 3, 5, and 7, the median is 5. This is because 5 is the number that sits exactly in the middle of the data set. If we have an even number, the median is the average of the two centermost values. For instance, if our data set is 2, 4, 6, and 8, the median would be the average of 4 and 6, which is 5. This method ensures that the median accurately represents the center of the data set, even when there is no single middle value. The median is less bothered by extreme values, making it a more stable measure in some cases. For example, in a data set of incomes where most people earn between $30,000 and $50,000, but a few earn millions, the mean would be skewed by the high incomes. The median, however, would provide a better sense of the typical income. This makes the median particularly useful in fields like economics and social sciences, where data can often be skewed by outliers. Understanding the median is essential for interpreting data correctly. It helps us to see the true center of our data, providing a clearer picture of what is typical or normal. Whether you're a student, a researcher, or just someone interested in data, knowing how to find and interpret the median is a valuable skill. So next time you encounter a data set, remember to look for the median. It might just give you the insight you need to understand the data better. The median is not just a number, it's a tool that helps us make sense of the world around us, one data set at a time. Now let's meet the mode, the value that appears most often in a data set. It's like the popular kid in school, always showing up. The mode is particularly useful when dealing with categorical data like colors or types of cars. It tells us which category is the most frequent. Keep in mind that a data set can have more than one mode. That's like having multiple popular kids, which is totally cool. So, which measure of central tendency should you use? This is a common question that data analysts, researchers, and even students often face. Choosing the right measure can significantly impact the insights you derive from your data. Let's delve deeper into the three main measures of central tendency: mean, median, and mode, and understand when to use each one effectively. Well, it depends on the data and what you want to find out. Each measure has its strengths and weaknesses, and the context of your data will guide your choice. For instance, if you're dealing with a dataset that is symmetrically distributed, the mean can be a powerful tool. It takes into account every value in your dataset, providing a comprehensive average. However, it's crucial to be aware of its sensitivity to outliers. The mean is a good choice when our data is nicely distributed without any extreme values. In such cases, the mean gives us a clear and accurate representation of the central point of our data. For example, if you're analyzing the test scores of a class where most students scored around the same range, the mean will provide a reliable average score. But remember, if there are a few students with exceptionally high or low scores, the mean might get skewed. The median is a better choice when we have extreme values, or our data is skewed. The median represents the middle value when all data points are arranged in ascending or descending order. This makes it a robust measure that isn't affected by outliers. For instance, if you're looking at household incomes in a region where a few individuals earn significantly more than the rest, the median will give you a better sense of the typical income than the mean. And the mode is perfect for categorical data. The mode is the value that appears most frequently in your dataset. It's particularly useful when you're dealing with non-numeric data or when you want to identify the most common category. For example, if you're analyzing survey responses about favorite ice cream flavors, the mode will tell you which flavor is the most popular among respondents. Remember, using all three measures can give you a more complete picture of your data. Each measure provides a different perspective, and together, they can help you understand the nuances of your dataset. By considering the mean, median, and mode, you can make more informed decisions and draw more accurate conclusions from your data. So next time you're faced with a dataset, take a moment to think about which measure of central tendency will best serve your analysis. Now let's talk about variability, the spread or dispersion of data. Think of it as the spice that makes data interesting. Variability tells us how much our values differ from each other. A small variability means our data points are clustered closely together, like a flock of birds. A large variability means our data points are more spread out, like a group of kids playing hide and seek. One of the most common ways to measure variability is with the standard deviation. It tells us how much, on average, each data point deviates from the mean. Calculating the standard deviation involves a bit of math, but don't worry, it's not rocket science. A small standard deviation means our data is clustered tightly around the mean, while a large standard deviation means it's more spread out. Now, let's see how these statistical tools play out in the world of education. Teachers use measures of central tendency and variability to understand student performance on tests. The mean score gives us an overall picture of how the class performed. The standard deviation tells us how spread out the scores are, indicating if there's a wide range of abilities in the classroom. That's a wrap on measures of central tendency and variability. We've learned that these statistical tools are essential for making sense of data. From the mean to the standard deviation, each measure provides unique insights into our data. So, next time you encounter a graph or chart, remember the power of statistics and the stories they tell.